Hello everyone, welcome to the next lecture on the SPSS. Today we will see about that how you can compute the probabilities using the binomial distribution in SPSS. Myself Dr. Garg, working in the School of Mathematics Thapar Institute, India. So what is the objective of this video is that we can see how we can solve such kind of the problem into the SPSS software. So let's start with this video without wasting any time. So first of all, whatever you have the problem is there, your target is always to express what is x is equal to something, x is greater than equal to something, or less than equal to something. So this is your first step will be always there. So if you write that this first line, what is that? Exactly two heads are there. So how you can write that? This is x is equal to 2. What is my x represents that? Number of the heads. What is the maximum number of the heads you have? When you toss the coin, how many times you toss the coin? 6 times. What is the maximum number of the coins you have tossed? This is a n, that is a 6. What is the p? Is the probability of the head. So what is the probability of the head? Head appears twice than of the tail. So what is that? We all know head plus tail is 1. So it means tail is my this. So head will be my 2 by 3. So this is the way you can compute the value of head and tail. So the probability of the head is my 2 by 3. So based on this, you can say now you have to write this. So remember these tips, whenever there is a equality sign, you are working on the PDF always. Whenever there is a greater than or less than sign, we are working on the CDF always. So since this is the equality sign, so we work on the PDF, and n is my finite. So it means this is my binomial distributions. So how you can apply into the SPSS? So you can go to the SPSS here. This is my SPSS. Go to the data view, click on the data view tab and define the variable as x. Make sure that this value must be the numeric. If it is not be the numeric, then you must change into the numeric type. Firstly click on here, then you can change that. Now once you are defining this as a numeric, click on this variable data view tab, and your target is to find the value at x is equal to 2. So input, this is my input target B. So you have to input this 2 into here. Now once you will input this value, now you can see our target is to find here. This equality is represent for my PDF. So go to this transform. You can click on this transform, and then you can click on this compute variable. Once you click on this compute variable, this window will appear. Remember always that your target is to find this value. You can see on the left hand side there is a x because you have defined x here. On this function group, since this equality is represent for my PDF, you can click, you can find on the PDF here, like here this is a CDF conversion, this you can click, find, you can scroll down, you can find the PDF as here. You can see once you will click on the PDF, now you have to see which distribution is here. This is my binomial. So once you are finding the binomial distribution, look about the binomial here. This is my PDF binomial. Once you will select this one and put this arrow key, it will go in the upside. So once you will select here, you can see the description will appear on the left hand side, and once you will select on this, press this arrow key, it will go in the upside down. So you can click on this, it will go here. Now there are the 3 question marks appear. What is the meaning of these 3 question mark is? The first question mark represents the quantity. What is that? What is the quantity means? You have to calculate the PDF at the point 2. It means this is my quantity, and this 2 is stored in the form of the x. So you have to replace this, you have to select this, put this arrow key and replace here as a x. What is the second number is n. Third one is the PROB is the probability. So in this particular example, what is your n and what is your p? You can see n is my 6, p is my 2 by 3. So you can input these values as here. N is my 6, p is my 2 by 3. So make sure that you can't write 2 by 3 as a 0.666. Instead of them, you have to write directly as 2 by 3. Once you can write all this expression, you can see still OK button is not activated. So what you can do that, you have to save your target value at this point. So you can save the output whatever you want to use, but without the space. Once you will complete this one, now you can see your OK button will activate. Click on this, you will get the required answer here. So once this execute will appears, it means there is no error found in the file. And once you will here, you can see on the window, you can see the output as here. Now since this is up to the 2 decimal places, how you can increase your decimal results? So in order to increase your decimal results, click on this variable view tab. Once you will click on this, and we want to increase the decimal of ANS1. So you can see ANS1 is here. Change the decimal portion are here. You can change their decimals to be say 5. Make sure that if it is 8, the maximum decimal you can take as 7. So if you want to change here as a 10, then the maximum decimal you can take as a 9. So now you can change as a 5. You can see the output as 3292 is the right answer. Look over the second part is there, how you can find at least 3 heads. So once you will write here, now since this is the greater than sign are there, it means you are working on the CDF. So firstly you have to express this in terms of the CDF. How you write that? I can write this in terms of here. So remember that what is my CDF is, you have to write in terms of less than or equality. So since equality is not be there, so I can write here as x less than equal to 2. So therefore I can write here as f of 2. So I can write this expression into the SPSS. What is that? This is my CDF of the binomial distribution. And what is the input of that? Whatever you have written inside this is my input. So how you can perform them? You can again open to the SPSS software. I can open here. I can delete the previous values are there. So I can right click them. I can clear this variable. I can right click clear this variable. Now you can see my input is my 2. So I can define a variable in the variable view as say x. Make sure that it must be the numeric. Otherwise you can click on this and here as a numeric. And then you can write here as a input as a 2. Once you will click as a input, now my expression is CDF binomial. So I can go to the transform. I can click on the compute variable. Now always press reset. Now you can see about the CDF. So this is my CDF. Look about the binomial. This is the CDF binomial. You can click on this. It will go upside B. The first one is represented as a quantity. So you can select the first x here. What is the n for this particular example is? N is my 6. P is my 2 by 3. So I can write here as 6 in the second question mark. I can delete 2 by 3 here. Also I need as a 1 minus. So I can express here as 1 minus of this. So I can write here as answer 1B. So I can press the OK. Now you can see this is the executives appear. So you can find the answer as here. So I can increase their decimals to be say 5, 7. So you will get this is the right answer of this. Look about the third part is there. We have to find at the most 3 heads are there. How you can find the at the most 3 heads? It means x less than equal to 3. So can you find this again this is a less than sign, so you have to write in the CDF form. This is nothing but f of 3. So what is that? This is my CDF of the binomial distribution and 3 is my input. So what you can do that? You can simply write define the new variable here as say y and make sure that it's a numeric. I can input as a 3. Now once input as a 3, now you can click on the CDF binomial. So I can click on the transform again, compute variable. I always press reset, find the CDF of the binomial, put arrow key. Now I want to find the CDF at the point 3 and 3 is stored in the form of the y. So I can select the y, I can put here. N in this particular example is my 6, probability is my 2 by 3. I can save this answer as say answer 1C. I can press OK. You can see if execute will appears, it means there is no error inside it. Now remember that in this case there is no need to write 1 minus, because in the expression there is no 1 minus are there. So you can see the output as here. You can change their decimal places to be say 5. This is the right answer of this. 0.31962 is the right answer of this. Look at the next example are there. So your first target is to express this in form of here. Now this is the expression for this. So this is a greater than or less than sign, so you have to express this in terms of the CDF. So how you write them? This is 1 minus x. What is the opposite of this? Is strictly less than 1, but we need here as the equality sign, so I can write here as less than equal to 0, or you can write here as f of 0. This is my CDF. What is the 0? Is my input. Now how you identify the distribution? What is the x is my here is, this is number of the cell phones which are defective. So what is the maximum number of the cell phone you have? The maximum number of the defective cell phone is my 10. What is the probability of the defective is 20 by 100, that is 1 by 5. So I can use, since n is my finite, so what is the meaning of that? This means this is my binomial distribution again. So I can express this formula 1 minus f0 into the SPSS. So how you can do that? I can clear this variable again. So you can delete all these variable are here. Now I can input the value x as my 0. So I can clear all these variables. So now since I need the input as my 0, you can again see input is my 0. So I want to express 1 minus f of 0. So 0 I input that, transform, compute variable, I can put the reset CDF of the binomial, put arrow. The first one is my x. What is the value of the n? You can see the n is my 10, p is my, either you can simply write 20 by 100, that's fine. So you can simply write here as n is my 10 and probability is my 20 divided by 100. And also we need as a 1 minus, this also need, so I can write here as 1 minus. So I can save this as question number 2 is there. So I can press OK. Now you can see answer 2, this is expression I have written, is execute is there, so it means there is no error. I can increase their decimal, or else you can see the exact answer is written here, or we can increase their decimal as here. This is the right answer. Look about the second part. What is that? This is the at the most 3 are defective. So it means at the most 3. So how you can write that? This is less than equal to 3. Again, since this is a less than sign, so it means we are working on the CDF. Again, it's same question are there. So it's a binomial distribution. How can I write as a CDF? This is strictly as f of 3. So I want to express this value into the SPSS software. So this is my input. So 3 is my input. So I can define the new variable as here, say y, and I can input as my 3 here. So again, you can go to the transform, compute, always press the reset button. I want a CDF at the point 3. So CDF of the binomial, press here. I save the answer as a y. N is my 10. You can again see n is my 10. Probability is 20 by 100. Or you can write as a 1 by 5. So it's a 20 by 100. Again, you can see OK is not be activated. So you can save the answer as say answer of 2B. I can press OK. You can see now it's execute. It means there is no error, and that is the right answer of this 87913 something. This is the 87913 is the right answer. What is the meaning of the none is defective? So what is that? None is defective. So how you can write that none? That is x is equal to 0. So your target of the third part is probability x is equal to 0. Now you can see that this is my equality. So it means this is my PDF. So you have to find the PDF of the binomial distribution. How you can do that? I can input the value here as, I can call as say y1. I can input, what is that, this is my input, so I can input the value as a 0. You can see I can write is input 0. Now I want to use the PDF binomial. I can reset them. Now you can search as a PDF. It's alphabetically are there. So now you can see this is the PDF. Again find the binomial, put the arrow key. This first question mark will be appears on here. N is my 10, probability is my 20 by 100. And since there is no 1 minus are there, so PDF is equality sign. So now I can save the answer as 2 of C. So remember, this is the PDF. Now once I will press OK, now it's execute. So you can see the answer is my 0.11. So I can increase the decimal places. So you can see 0.10737 is the right answer. You can see another example are there. What is the probability if the 2 bombs are enough to destroy the bridge? What is the probability that out of the 10 bombs the bridge will destroy? So your target will be here. Now again your target, this is my less than or greater than sign, so it means it's a CDF. What is the maximum number of the bombs you have? This is my 10. What is the maximum number of the bombs you have? Out of 10 are here, so that's a finite. And what is the probability of hitting the target? So this is the probability of hitting the target. So since n is finite, so again it means it is my binomial. So you are working on the CDF binomial. So firstly express this in terms of the CDF. CDF means less than equal to. How you convert them into the CDF is 1 minus x is strictly less than 2, but we need as a equality also in the CDF. I can write here as x less than equal to 1, or since it's a CDF, so I can write here as f of 1. So therefore, what is the meaning of that? This 1 is my input. This f is nothing but my CDF of the binomial. So I can put input as a 1. I can clear all these variables. So now I can replace the value here as a 1. Now I want as a 1 minus CDF of the 1. So again you can go to the transform, compute variable, you can reset this button, search for the CDF, search for the CDF binomial, put here, first is x. What is the n in this case is? N is my 10 and p is my 0.6. So n is my 10, p is my 0.6, and I need as a 1 minus. So 1 minus, I can save the answer as answer of say question number 3rd. So you can see that this is a 1 minus of f of 1. So I can put as OK. You can see the output is executed. So you can see the answer as 1. But you can see that it's exactly 1, but probability can't be 1. So you can see if you increase your decimal places, say 5, now you can see that exact answer is 0.99832. The right answer is 0.99832 is there. Look at the another one is there. So a fair coin is tossed, this one. If doublet is considered as a success, what is the probability of getting at least 2 success? This is the first part. What is the probability of getting at the most? Second part. And this is the probability of getting exactly 2 are there. So what is the meaning of that? Since this is the equality, so this is solved with the help of the PDF. This is the less than greater than sign, so this is solved with the help of the CDF. This is also in the form of the CDF. So I can firstly express this in form of the CDF. I can write this as less than equal to 1. So I can write it as f of 1. How you can write this in the CDF is, this is nothing but f of 2, this is here. Now to identify the distribution. What is my x? X is the number of the doublet. Number of the dice on which doublet shows. So what is the maximum number of the dice you have? So what is the maximum number of the dice you have thrown is 5. That's again is finite. What is the probability of getting the doublet? So what is the meaning of the doublet is 1 1, 2 2, and last is 6, 6. So what is the probability of getting the doublet is 6 by 36, that is 1 by 6. So now n is my finite, so whenever n is finite you have to apply the binomial. So how you can express this as a binomial is, this one is my input, f is my CDF of the binomial distribution. So that's very simply, you can input the value of the x as a 1. I can delete this value, and you can go to the transform, compute variable. So CDF binomial, express x here, and what is the probability of this is, probability is my 1 by 6, n is my 5. So I can write here as this, n is my 5 and probability is 1 by 6. I need a 1 minus, you can write here as a 1 minus, answer is this value. So now is execute. So you can see the answer is here. Similarly, you can do your rest of the part as yourself. I can do this part. This is the PDF. You can input here as say 2. I can rename as a y. You can go to the transform and search for the PDF. You can search for the PDF and then for the binomial, and here, so you can see this is my y, n is my, you can find the n is my 5, p is my 1 by 6, 5 and 1 by 6. So this is the answer of here. Now it's execute. So you can see the answer is my here. So this is the way you can solve this PDF binomial distributions are there. So this you can do it yourself. So if you feel any doubt, you may ask. Otherwise we will see the Poisson distribution in our next class. Till then, best of luck.